recording this. Is it working? All right. So today's lesson is the second in our unit on rational numbers. We're going to be using the number line today to model the addition of integers. So we started doing a little bit of that last class. We'll be doing that again. And the biggest standard that we're covering is the second one, where we're representing addition and subtraction on a horizontal or vertical number line. Okay, let's go into exercise 1, real world introduction to integer addition. Suppose you received $10 from your grandmother for your birthday. You spent $4 on snacks. Using addition, how would you write an equation to represent this situation? I'll take volunteers for this. Guys, please have Chromebooks closed. We're not using them after all, so we don't need them. Grace?
Would you do 10 plus 4 in between these lines?
Okay, you're thinking absolute value of 4? Not quite. Another try, Irene?
10 plus negative 4.
10 plus negative 4, good. And an equation, when you see the word equation, there always has to be an equals sign. If you see the word expression, there does not need to be an equal sign, but equation means that something equals something else. Jake?
Whenever it says using addition for this for these type of equations, wouldn't you have to use that every time?
No, not necessarily. Let's finish this equation, then we'll talk about how you could write that using subtraction as well. Okay? So what would the answer be? If you have $10 and you spent $4, how much would you have left? Elena? You would have $6 left. So that's the equation they're looking for. Now, Jake said, wouldn't you always have to use addition? How could you write this equation using subtraction? That would probably be what you might think of first before we started this unit. Jake?
Minus 4 plus 10. I don't know.
You're making it too complicated. Before you learned about integers, when you were in 3rd grade, how would you have written? How would you have done this?
0 minus 4.
Oh my God. You're too far past 3rd grade to remember. Let's see, Eli, what do you think?
Oh my God.
Yeah, listen, Jake, Eli, say it again. Just 10 minus 4. That's how we would write this using subtraction. All right, guys, give me your attention again, please. All right, so just with subtraction, we could say 10 minus 4 equals 6, but we are just focusing on addition right now, so we're going to write this as 10 plus a negative 4 equals 6. Then we're going to model the equation on a number line. So what we did last time is we would start on 0, and we would go 10 units to the right. And then, I have the advantage of being able to switch colors. We go 4 units to the left. And we end on 6. So circle the number where you end. We're going to be modifying the way we do this slightly, but go ahead and do this one this way, and then I'll talk to you about how we're going to modify it. Example 1, we're going to model addition on the number line. We're going to fill in these blanks kind of quickly, and then we're going to apply it over on the next page. So the first thing we always do is place the tail of the arrow on 0. And we are going to talk specifically about how we're going to find the sum of negative 2 plus 3. We're going to draw, instead of making the little hops, we're going to draw a straight arrow. We're going to draw the arrow until we get 2 units to the left of 0, and we're going to stop at negative 2. The direction of the arrow will be to the left. Then you're going to start the next arrow at the end of the first arrow, or at negative 2. So the second one will start where the first one ended. And you're going to draw the second arrow 3 units to the right, because we have plus 3. We're coming up from negative 2. And then you will end up at 1. I'm now going to go to the number line and go through all of this, but I thought it might be helpful just to get those blanks filled in. Okay. So the first thing that we're going to do is to place the tail of the arrow on 0. So I'm going to start right here on 0. Let me just write what we're doing again. -2 plus 3. We're going to draw a straight arrow and stop at -2. So instead of doing the little hops, you can just kind of count with your finger 1, 2 units and stop your arrow there. Our next arrow is going to start where this one ended and go 3 units to the right. 1, 2, 3. And it's going to stop on negative, or not negative, it's going to stop on +1. Okay, G is asking us to repeat the process for the expression 3 plus -2. I'm just writing it out larger here. You have it already on your paper. Okay, who can tell me how to go through that process? Any volunteers? Let's see, Zoe.
Start at 0.
Okay.
And then go to the right to 3.
Okay, we're going to go to the right 3 units.
And
Okay.
then go back 2.
Okay, back 2 units. And I end where?
1.
1. Good. I think you guys just have, oh no, you do have 2 number lines. Good. What can you say about the sum of -2 plus 3 and 3 plus -2? So the sum of -2 plus 3 was 1. The sum of 3 plus -2 was 1. So what can we say about those sums? They're equal. They're the same. So does the order matter when we add numbers? No, it didn't matter when you did addition of positive numbers. Like if you do 4 plus 3, that's 7. And if you do 3 plus 4, that's also 7. It also does not matter when we add integers. So if we include negative numbers, the order still does not matter. And does anyone remember, maybe you never learned or maybe you did, what the name of the property is that tells us that numbers can be switched? Starts with a C. Eli? It is the commutative property. Excellent. So we could say no, because addition is commutative. Okay, any questions about anything we've done so far? Okay, let's go on to example 2. Example 2, we're going to be talking about expressing absolute value as the length of an arrow on the real number line. And the question asks us, how does absolute value determine the arrow length for -2? Use the number line provided to support your answer. So if we were to draw an arrow to represent -2, what would that look like? Volunteer? Irene?
You would go from 0 and go 2 over to the left.
Okay, so we would go from 0 over to the left, -2. Now, what is the length of that arrow? Reagan, what would you say the length of that arrow is?
2.
It's 2 units. So the absolute value of -2 is just 2. And the length of the arrow that we draw, length is always a positive number. So when we refer to length, we say this arrow is 2 units long, which is also its absolute value. Questions about that? Okay, let's go on to B. How does absolute value determine the arrow length for 3? Ross, tell me how I would draw an arrow for 3.
You go 3 spaces from 0 to the right.
Okay, start at 0, go 3 spaces to the right. And what is the length of that arrow, Ross?
3.
3 units. And we know that the absolute value of 3 is 3. Part C says, describe how the absolute value helps you represent -10 on a number line. That's kind of one of those weird questions. Does anybody want to take a stab at how they want you to answer that? Describe how the absolute value helps you represent -10 on a number line. This is a really obvious answer. Jake?
10 to the left.
Yeah, you would draw an arrow 10 units to the left. So the absolute value of -10 is 10, so that's how we know how long to draw the arrow. Okay, that's another one of those kind of obvious questions. Okay, what I would like you to do, exercise 2, you are going to take, there's only a couple there, take about 2 minutes to complete exercise 2, and then we will talk about those. I hear rustling pages, so I think pretty much everyone is done and moving on to look ahead at the next section. So let's just go over these quickly. Sky, can you explain to me how I would make a model for part A?
I started at 0 and I moved to the left 6 units.
Okay, to the left 6 units, and then,
I moved to the right 4,
okay, and where did you end up?
-2.
Okay. You ended up at -2, so we can say that -6 plus 4 is -2. Excellent. Taryn, can you explain part B?
From 0
Uh-huh.
to the right 3,
Uh-huh.
and then go from 3 back 8 to the left.
Okay.
And up to 5.
Good. Whoops, I went too far. Okay, so 3 plus -8 is -5. Any questions about this? It looks good as I was walking around. Okay. All right, example 3, we have a number line model to start with, and we're supposed to find the sum of the integers represented in the diagram. So let's start by writing an equation to express the sum. Kaylin, how do you think you would write that equation? Well, work from the bottom up. So the bottom is the first thing that you would have drawn if you were making this.
5.
Good. Okay, so we're going to start with this 5 because it's on the bottom. So 5. Good. 5 plus -2 plus 3. We'll just work from the bottom up. And what is the answer to that equation, Adria?
6.
Good. You can see that we end up right here at 6. Okay, if we were playing the integer game, what 3 cards are represented in that model? Let's see. Is Pat not here? Okay. Michaela, what cards are represented in the model?
5, -2, and 3.
Good. 5, -2, and 3. I think the how did you know part is kind of one of those obvious questions, but Michaela, how did you know that? It kind of does just say it. So I think what they're looking for there is that the numbers are shown above the arrows so we can tell by each arrow. But yeah, it just kind of says it. Okay, in what ways does this model differ from the ones we used in lesson 1? So how is this different? Jake?
Wait, oh, I was gonna ask for part A,
Uh-huh.
if you have more than one negative or more than one positive numbers, could you just add all of the positive numbers together and then add the negatives and then?
Yep, you absolutely can do that. So Jake asked, in case you all didn't hear that, if you have more than one positive number and also more than one negative number, could you add all the positives together and then add all the negatives together and then do that equation? You absolutely can, because addition is commutative. It doesn't matter what order we add or subtract in, so that would absolutely work. Okay, so part C just asks how this model differs from the ones we used in lesson 1. Zoe, how is this different from how we did it on Friday?
We didn't we didn't hop.
Yeah, on Friday we did the hops, and we're not doing the hops here. So we're using arrows instead of showing each hop. You could just say arrows instead of hops. That's not something that's going to show up on your next test or anything like that. Arrows instead of hops is fine there. Okay, part D asks, Can you make a connection between the sum of 6, or the answer, and where the third arrow ends on the number line? This is another really obvious question. What's the connection between the sum of 6 and where the third arrow ends? Irene?
They're the answer.
Yeah, the arrow ends on 6. That's what tells us the answer. So the final position is 6. And the sum is 6. You can answer it that simply. Would the sum change if we change the order in which we add the numbers? So if we started with -2, we did -2 plus 3 plus 5. McKenna, would the answer change?
No,
No, why not?
because they'll just all add up to do the same thing.
But why? Why would they all add up to be the same thing? Do you remember the name of that property that tells us they all add up to be the same thing? Anybody remember the name of the property? Adria? Because of the commutative property. Doesn't ask us to describe, but we could because it's commutative. Okay, now would the diagram change, Riley? If we changed the order and we did -2 plus 3 plus 5, would that change what this diagram looked like?
Yeah,
Yeah, how would it change?
because the arrow would go back 2 and then up 3 and then up 5.
Okay, so our arrows would be in a different order. We'd still have these arrows, but they would start in different places. Okay, good. So if you want to explain that, I'm not going to write that out there, but the diagram would change because the arrows would change their position. Okay, this was a fairly nice lesson because now for the remainder of the lesson, you get to spend some time playing the integer game. And it asks you to use the number line to practice counting on. So as you're playing, when you first get your cards, use the number lines on your desk to figure out the sum of the cards you have in your hand so you kind of know what you're looking for as you go to 0. So I'm going to shut this off. We'll come back to the lesson in just a minute. Let's see, I can't find my...